All right, we're going to be getting into our first lesson of the school year today. I'm going to try to keep this as short and simple as I can. I would advise that you have some colors available to you as you complete your guided notes. I love colors and pens and highlighters. You're going to see I use it all over the place here. So we're just going to get right into the vocabulary. I do apologize. This first section, actually the first section of a lot of chapters, is very vocabulary heavy as we kind of get started and set up. So the first thing you need to know is a point. It's just a location in space, somewhere in space. It has no size, and it's represented by a small dot, and we name it with a capital letter. As such, there's the point A, and we actually call it point A or A. Always a capital letter. Very important to know. If you say point A with a lowercase letter, that's going to be wrong. Geometry is very detailed. Like, you need to make sure you're very aware of your details. Next thing we got is a line. If you take 2 points, you can make a line out of it. My apologies for sneezing. A line is a series of points. It's actually an infinite amount of points that extends in two opposite directions without an end. And so it looks something like this. We have our infinite amount of points, and something to keep in mind is arrows. Sorry, I didn't mean to circle the L. Arrows. Lines have arrows. That means it goes on forever in that direction. So very, very important to know. We name it by saying line L. That's the lowercase one, which you'll see a little bit. But most of what we're going to do is we're going to be saying line, whatever 2 points are involved in that. So line AB. And we need to make sure that we also include those arrows. See those arrows again showing up? That means it's a line. That's a line. So line AB. It doesn't matter the order. You could say line BA as well. If it had multiple points on it, like point C, you could say line AC. That's the same thing as saying line AB, which is the same thing as saying line BC, so on and so forth. Just any 2 points on the line with arrows. We have 1 point, 2 points, at least 2 points make a line. Now 3 points is going to make what we call a plane, which is a flat surface that has no thickness. It may contain lines, and it could contain points, and it's going to extend in every single direction, such as this. Think of like a wall or your floor in your house. Like, your floor is a plane, a flat surface. We name it by saying plane M. You see a little M in the corner that doesn't have a point or anything attached to it, like C point A. So that's how we could say plane M, or we use any 3 points. So a point is 1 point, a line is at least 2 points, and then a plane is at least 3 points. I guess I should include the S down there. So when we do the examples, by the way, I want you to pause the video and try doing the examples on your own first, and then you continue the video to check your work. So at this time, pause the video, try to do this problem on your own, and then continue to check your work. So it says name the plane in 2 different ways. It could be any 3 points. Remember, any 3 points. These are now points on the corner. See how R is outside the plane? So we're not just going to say, oh, it's plane R, because R would have to be on the inside. So we could say plane, pick your 3 favorite. I like a URT, plain ERT, or plain SUR, like Big Sur, plain Sir. So it doesn't matter as long as you use any 3. We're going to come back to this in just a second. Some more vocabulary. This term collinear are points that lie on the same line. So if you go back here, just like, words that start with co-pilots fly the same plane. Cooperate is working on the same thing, like working together to accomplish the same task. That co is kind of doing things similarly or the same. So when we go back, talking about any of these points that are collinear, well, do you see any of them that would lie on the same line? Yeah. RS, like you could say RS. Oops, no, sorry. I want to say points R and S are on the same line. However, SU, there's no line that goes through it, so SU would not be collinear. So you could say SR, you could say RU, you could say T and U. You cannot say RT, there's no line that goes through those 2 points. So continuing on, we got, we don't really need defined terms, actually. Just cross that one out. A line segment, or just simply known as a segment, we're going to say segment most of the time, consists of endpoints, not necessarily AB, but endpoints between those. So for instance, here we have 2 endpoints, A, B, and every point between them. Notice there's no arrows this time. There are no arrows. It's only a piece of a line. And again, you could say segment AB. We draw the shape above it, right? Like line has arrows, right? If we're just doing a segment, we don't have arrows. And we could say BA. The order of these doesn't matter as long as it's the 2 endpoints. Very important now, it has to be the 2 endpoints. Because if you say AC, you're only talking about that much of the segment. So very important. Again, details are really, really key here in geometry. We then have, there's the naming, array. So we had a line that had 2 arrows, a segment that had no arrows, and now we're going to have an array that has 1 arrow. And it's going to consist of an endpoint and everything to one side of it. So you can see here we have endpoints and then arrows going in one direction. So it starts here, has a beginning and no end. This is the most important one though, because the naming is a little bit tricky. Because you name it, you always name it with the arrow pointing to the right, using the 2 points with the endpoint first. So we always say it's array. Where does it start? It starts at A and goes through or goes in the direction of B. Over here, actually, let me leave it like this. Over here, this next example, we still would name it array going from left to right, but the starting point is B now. See where it starts right here? Is B, and it goes in the direction of A. So that's where arrays get a little confusing, and this is the only one where order matters. The order of the points matters. Because if you say array A, B, that's saying you're starting at A and going through B, or in this case, starting at A and going through B that way. So it's a whole different thing. A little bit more vocab, opposite rays. These are 2 rays that go in opposite directions. They make a line, but share the same starting point. So for instance, here you could see ray CA. Notice how it's written. Starts at C, goes in the direction of A. Starts at C, goes in the direction of A. And then CB starts at C, goes in the direction of B, are opposite rays, and they end up making just one smooth, clean line. Coplanar, just like collinear was the same line, coplanar are points and lines that are on the same plane. Intersection, you probably see intersections in the streets when you're driving around. It's every point or a point that something has in common. So for instance, 2 lines cross or 2 segments cross, boom, right there, point B would be their intersection, just like in streets. And even sometimes you see, like I know in Long Beach, there's one of these where you have 3 streets that cross and they would all share 1 point. That's the intersection. So at this point, that's all the vocabulary that we're going to be covering here. I want you to, at this point, pause the video and try all of these examples on your own. And once you've tried them all, resume the video and then check your work. We're almost done already. All right, cool. Assuming you've already tried all these examples and now we're going back to check our work. Well, we've already done example 2. In the figure below, name a pair of opposite rays. So we need to find 2 points and maybe a 1 in between it, which is Y. For instance, if we start at Y and go in the direction of W. So we start at Y and go in the direction of W. And then we start at Y again because we have to start at the same starting location and go in the direction of Z. It creates a whole line. Those are the opposite rays. They start at the same point and go in opposite directions. I know it's common to say WY and ZY, but notice they have an overlap. We don't want overlap. We just want the same starting location. They should both start with the Y. And then it says, what is the intersection of the opposite rays? Intersection, remember, means what do they have in common, or what do they share, or where do they touch? You can't see my hand gestures, but I'm doing hand gestures. Where do they touch? Right here at point Y, you can see it's what they both have in common. They both have point Y. So that's how we know this is their intersection. Continue on, example 3, name 3 planes that intersect at point P. This is a lot harder to see on paper. So we have point P here, and you're basically saying in a cube or a box, and if you have a box, it might even help if you like put your finger at one of the corners and say, this is P, or even draw maybe. What 3 sides of the box touch point P? Well, I see the top of the box. Okay, so I can say plane, any 3 points that are touching the red or highlighted in red. So I might say P, M, N. Okay. I also see the front of the box includes point P. Okay, so I can say plane P, P-O-T, plane pot, like a pot in your kitchen, I guess. And notice how I'm highlighting this. Like I'm using my pen to actually draw this out because that's the best way that I can see this. And by the way, if you name these different, like plane P-O-T, you have to name it P-O-T. You could have said plane P-Q-T, or you could have said plane Q-T-O. You don't even have to include P if you don't want to. And then the last one, the third side, looks like this side of the box over here, which would be plane P, oh God, P-M-R. Cool. And then to find out, are P, M, and Q collinear? Remember, that means the same line. Are these 3 points on the same line? Well, let's draw it. If we start at P, go to M, and go to, oh wait, where's Q? Sorry. P to M to Q. Does that make a straight line? Well, we can already see it makes a Z, so that would be no. But are they coplanar? Are they on the same side? Are they on the same side of the box? Yes, indeed they are. They're on the left side of the box there. So the difference between collinear and coplanar. Example 4, what is the intersection of plane HGC and AED? So let's do this. Let's go HGC. I'm tracing. So I can see it's the back of the, and if I go back to H, I can see it crosses through the back of the box. So this is plane HGC. It's the back of the box. And then I'm going to say, what is, AED. AED. Okay, so this is going to be the left side of the box. So I can highlight that. Where is the overlap happening? And that is going to be not just a point now, because 2 lines intersect at a single point, but these planes intersect at all of those points there at that spot. So it's going to be segment HD, that whole corner down the back of the box there is going to be the intersection here. So all lines intersect at a point, and all planes intersect at a line or a line segment. Just a nice fun fact to know. Last 2 examples, shade the plane that contains X, Y, and Z. So I like to do start at X, go to Y, and go to Z. And I can already see it's starting to trace the back side of that pyramid there. So I can just continue my way back down to X. And then I will nicely shade the back part there. So it's good to trace X to Y to Z and back to X, and it makes a nice shaded plane. And you can then see exactly what you're trying to shade. All right, last example. Last one. In this figure, not necessarily at the right at the bottom, are there any places where at least four planes, four surfaces, four sides of the shape come together and intersect? Maybe at the tip there, I can see this side, this side, this side, and then the two back sides all come together at the peak there at point T. And you could say all sides except, remember it says explain, don't forget to explain, all sides except the bottom touch at point T. And I believe actually at that point, that's it. So thank you for doing your first notes. Hopefully it looks like I kept this to a pretty reasonable amount of time. I'm trying to keep this no longer than 30 minutes. Ideally, my target is 20 minutes for each section of notes. And it's just notes. That's all you have to do. Watch the video, do the notes, and then come to class with questions tomorrow. All right, and that's it. Take care, and I will see you in class.